Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. PCC, Pyridinium chlorochromate, is a mild oxidizing agent commonly used in organic chemistry. Its key property is that it oxidizes primary alcohols to aldehydes, stopping before carboxylic acid, and oxidize secondary alcohols to ketones. It does not perform reductions, halogenations, or ring-opening reactions. Moving on to the next step. The transformation shown is cyclohexanone-cyclohexanol, which is a reduction ketone to alcohol. PCC is an oxidizing agent, not a reducing agent, so it cannot perform this transformation. Option A is incorrect. Moving on to the next step. The transformation shown is cyclohexanol-cyclohexanone, which is the oxidation of a secondary alcohol to a ketone. PCC is well known for exactly this type of transformation, oxidizing secondary alcohols to ketones under mild conditions. Option B is correct. And for the final step. The transformation shown is cyclohexanol chlorocyclohexane, which is a nucleophilic substitution or halogenation reaction replacing OH with Cl. PCC does not perform halogenations, it is purely an oxidant. Option C is incorrect. The transformation shown is cyclohexanone, a linear dicarboxylic acid, ring opening with two CO2H groups. PCC does not cause ring opening or convert ketones to carboxylic acids. This would require a very different set of reagents, example, oxidative cleavage. Option D is incorrect. Conclusion, only option B, oxidation of cyclohexanol, secondary alcohol, to cyclohexanone, ketone, is a reaction for which PCC is a suitable and well-established reagent. Therefore, the correct answer is B. Therefore, the correct answer is option B.